Hi, everybody. Thanks for coming, especially after last night, so I appreciate it. My name is Or. I'm a senior product manager on the Lambda team, and I'm here today to talk to you about authoring and deploying serverless applications with a special focus on AWS SAM. And so this is a bit about what we'll be covering today. I'll start with a brief intro on what a serverless app is, just to make sure we're all on the same page. I'll then get into the benefits of going serverless. And I'll tie those benefits back into real life with a couple of customer examples. And then we'll get into what it takes to author a serverless application, author and deploy a serverless application, from writing that first line of code to the end goal, which is safely deploying a serverless application to production. And we'll do this by first going over the various tools at our disposal for authoring, testing, and debugging serverless applications. And then we'll get into deploying serverless applications. And we'll briefly review existing tooling for automating serverless deployments. And then we'll get into something new that launched this week that can help you adhere to best practices, minimize deployment risk, and reduce the blast radius. So as I mentioned, just really quickly to make sure everybody's on the same page, what is a serverless application? So it starts with that component in the middle over there, your Lambda function, which is your compute. And you can write it runs your code. You can write it in any of our supported languages today, which is .NET, Java, Python, and Node.js. And very soon, as was announced yesterday, Go is going to join our family of supported languages, which we're pretty excited about. And your function is triggered by an event. That event can come either from an event source, such as S3 or SNS. It can also just be a Lambda invoke API call that you make directly to Lambda. Once your function is invoked, then your code runs. And your code could do anything you'd like it to do. So it could call any downstream service you'd like. Why are we all here today? What are the benefits of going serverless? Well, there are 4 key benefits. First, there are no servers to provision or manage. So no capacity plannings, no installing security patches. We hear customers tell us that now they can take a large team that was mostly focused on keeping infrastructure up and running and repurpose that team, or a large portion of it, to efforts and projects that drive business value. And I mentioned capacity plannings. So with Lambda, questions such as, how many servers do I need? Am I provisioned sufficiently for peak? Conversely, am I underutilizing my fleet? Those questions go away with Lambda, because Lambda scales up and down based on incoming traffic without you having to worry about it. And that brings me to my third point, which is you never pay for idle. You only pay for requests that are coming in and for compute time. So if your application is not doing something that's valuable for your business, you pay nothing. And lastly, Lambda has fault tolerance built in, which strips away the complexity of having to deal with architecting across availability zones. Now, these benefits are becoming clearer and clearer, and we're seeing more and more customers migrating to serverless. And just to give you a couple of brief examples, FINRA is processing over 500 billion stock trades daily using Lambda. And since they went serverless, they report lower processing time, lower costs, and most importantly for them, scalability is not an issue, and they can scale 3 to 4x this amount without them having to worry about it, without any action needed to be taken by the team. Another cool example is Thomson Reuters Product Insights, which is a web analytics platform that processes up to 4,000 events per second. They built this system in less than 5 months. It requires very little maintenance. And again, scalability is cited to be the main benefit for them, with recent spiky events such as Brexit and the US elections coming and going with no actions needed to be taken by the team. We on the Lambda team, as we work with these customers, help them build their serverless applications, we learn more about what it takes to build a serverless application, what it takes to author and deploy a serverless application. And last year, well, not on this stage, but on a similar stage somewhere in a hotel nearby, I was talking about application lifecycle management. And I showed this diagram that you see now. I talked about how you first have to author your code, which you could do in any ID you'd like. You then have to package or build your deployment package, your Lambda deployment package. You then have to test your application before eventually deploying it to multiple environments or to production. Now, realistically, this flow encapsulates two different flows within it. The first flow is the author test debug loop. And that's when we write our code, we think it's ready, we test it. It's not ready. We debug, we rewrite it, and we can go on and on within this loop. Now, we're usually well, let me rephrase. I remember from my days as a developer that I was extremely intolerant towards any inefficiencies in this flow. So we'd like this flow, or our dev environment, when we're immersed in this flow, to be as tight as possible, to be as quick as possible, to provide us with easy to consume feedback on what's going on. And once we think we're ready, once we think our code is done, that's when we check in. And after we check in, the second flow essentially kicks off. And the second flow is the automated deployment process. And that's when we have some orchestration mechanism that picks up our code from our code repo and puts it through the build process where our code is packaged and or built. We then have to test our code. And that mechanism essentially after that also deploys our code to multiple environments. And we'll start with the first flow here. So the first thing we need to understand is that different tools fit different use cases. And so just like I would use scissors to cut paper and the chainsaw to cut wood, and it's probably not a good idea to mix those two, I'd probably want to choose the appropriate tool for the type of application that I'm trying to build. So for example, if I'm trying to build something that's simple, let's say a chatbot or an Alexa skill, something that probably has one or just several Lambda functions, I'm the only collaborator, or I'm the only contributor, there's no code repo behind me. I'd like to ideally write my code somewhere that's close to the actual Lambda environment, something that a tool that provides me with that quick and easy to consume feedback loop. And so I'd probably like to use something like the Lambda console. The only issue with the Lambda console is that up until this week, it felt more like an AWS console. It felt less like a great place to write code in. So I'm happy to introduce the new and improved Lambda console, which we actually announced yesterday. And this new layout is actually optimized for that quick author test debug loop. It's optimized to give you that quick feedback. And that's true for a few reasons. First, the Lambda editor has now been overhauled to be powered by the newly announced AWS Cloud9. And so you can now edit multiple files within your deployment package on the Lambda console. You can, and most importantly, you can actually immerse yourself in this IDE-like experience and author your code, run it, and view the execution results right without leaving the context that you're in, just like within an IDE. Secondly, we released a function graph or function designer. And that's essentially a visualization of what flows into your Lambda function and what flows out of it. So you can really easily see the event sources that are set up to trigger your function, and also the downstream resources that your function has permissions to access. And lastly, we overhauled the monitoring view. So now it includes interactive graphs that allow you to zoom into and out of any time frame. And for each time frame, you can actually jump to the logs or metrics for that specific time frame that you chose. And so again, shortening that feedback loop, allowing you to narrow the information you need down, scope it down to exactly what you're trying to consume. And before we go any further, let me just quickly show you how that looks like. Okay. So we actually introduced this new Lambda console in a couple of waves in the last 2 months. And one thing we did was we completely reduced the time it takes to create a Lambda function, actually. Let me just call this reinvent demo. I'll create a new role from templates, and I'll call it, again, reinvent role. I'll just choose recognition permissions here just for fun. And I click on create. And so again, this is all I had to do to create a Lambda function, to quickly get started. I just have to enter a name. The runtime is Node.js by default, but you can obviously change that, and select a role. Now, the first view I land on is that function graph, the function designer I mentioned. So as you can see, my function is here on the middle. On the left, I can see triggers that are added to my function. Currently, there are none. But if, for example, I click on a trigger here from the left, let's select API gateway in this case. Let's zoom in a little bit. Then API gateway is added as a trigger on the left. And you'll notice that once API gateway is selected here, the panel below changes as well. So this function graph actually acts as a navigational construct on this page as well. So once the trigger is selected, I can actually scroll down here and configure that trigger. Now, in this specific case, I just want to remove that trigger for now. Now, on the right, I have the resources that my function can access. And so we have recognition, because we added that to our function's execution role. We also have CloudWatch logs, because any function, any role created on the console will get these permissions by default, so your function can actually emit logs to CloudWatch. Now, the cool thing here, if I click on one of these, so let's click on recognition, for example, and scroll down, I can actually see in an easy-to-consume manner what kind of actions my function can perform and on which resources. And I can see that either by resource or by action. So I can see here the 3 actions that my function can perform, and I can see the resources on which it can perform those actions. Now, let's go back to our function and jump into the new editor. Before we do that, I'd just like to quickly upload a deployment package. And this is a really silly bot that I built. It's really simple. All it does is essentially take in a question and give you an excuse on why it can't answer that question. And the excuses can be interesting, so bear with me as we go through this. OK, so the first thing I'd like to show you is I can quickly go into full screen mode. And again, get into that IDE-like experience. And I can see all the files in my deployment package here on the left. And so, for example, I don't need this package.lock JSON file, so let's just remove it. I don't need this weird Mac OS X folder, so let's remove that as well. And I'm left with my node module and with my index.js. And now, I also get quick feedback on what's going on here. So this variable is not defined, so let's just quickly define it. Once I change my code, I can actually save my deployment package right here. Deployment package has been saved. And now, let's just go into the next phase, which is testing my function. So let's see what happens here. Once I click on test, and this is another improvement we added a month ago, you can actually create multiple test events, and those will get persisted. So those will be carried along with you on any machine you use. And so let's just quickly create a test event. I'll call this time. And I'll just ask, what is the time? Now, once I do this, I can simply create my test event. And now, as I click here, I can actually see my test event that I created. I can just click on test. And I see my response right here below. So I get my response. I get my log information. I actually get visualization here on the right-hand side here on what actually happened and some important metrics like max memory used and time of execution. So I mentioned I could do multiple events here. So I can create a new one. And let's call this reInvent, and let's ask what launched at reInvent. And now I can see my 2 test events. I can actually switch between those and use those to invoke my function. So I can run test again. Yep, stupid excuses. And again, just demonstrating really quickly how easy it is now to just go through that loop on the Lambda console when that situation arises. One last thing I'd like to show you on the console is the monitoring view I mentioned. So just jumping to a function that has a bunch of invocations here. And as you can see, now I can actually go over the graph. I can see information really quickly, such as max, average, min time. In this case, this is the duration your function took to execute. And I could do things like essentially scroll into a specific piece of the data that I'm interested in, and then jump directly to CloudWatch, directly to the logs. And so what I did here was essentially jump to this 2.5-hour period, and I can examine the logs for that specific period really easily. And I can do that for any time frame I choose. OK, so that was the Lambda console. One quick thing I'd like to make sure everybody's aware of is that, again, making sure that experience is convenient and quick, we also added a bunch of keyboard shortcuts for the important actions that you would need to take while you're in that loop. So those are all listed here on the screen. The one thing I will call out, though, is the first one, the full screen one, which is Command-Shift-F on Mac, Control-Shift-F on PC. And that's the keyboard shortcut that brings you into that immersive full screen experience that I just showed you. So OK, great. We went through the simple application that can be built on the Lambda console. That's nice. But realistically, most of us have more complex applications. Most of us have collaborators, code repos behind us. And most importantly, most applications actually comprise of dozens of resources and multiple Lambda functions, and not just one Lambda function and one event source. And so for these type of applications, we actually have 2 components that we would need to author. The first one is our code, which is always going to be there. And the second component is actually our application. We need to have an easy way to define our application, define the resources within our application in an easy manner. And so for those of you who haven't already, meet SAM, which is our serverless application model. And the serverless application model is essentially a specification that extends CloudFormation and is optimized for serverless. It lets you define 3 resource types that are commonly used in serverless applications: API gateway APIs, Lambda functions, and DynamoDB tables. And the important thing to note here is that SAM is essentially a CloudFormation template under the covers. And so you can define any CloudFormation resource you'd like within your SAM template, and that's simply going to work. Now, I mentioned CloudFormation, so I'll just briefly go over what CloudFormation is for those of you who are less familiar. CloudFormation is our service for defining, provisioning, and managing a collection of related AWS resources. That collection, in CloudFormation terms, is referred to as a stack. And a stack can be defined with a template that can be in either YAML or JSON. And CloudFormation can take that template that you wrote and essentially provision resources and then manage them in your account. And CloudFormation is a great and powerful resource. The only issue is that it was built years ago when serverless wasn't even a sparkle in someone's eyes yet. And so it's optimized for infrastructure, less so for serverless. And that's the gap that SAM is trying to bridge. So what is a SAM template, essentially? This is a really simple one. And what I'm doing here is I have a Lambda function defined here, a serverless function, which is translated under the covers to a Lambda function. Below that, you can see I'm defining a couple of Lambda function properties. So I have a link to the code, I have my handler, I have a runtime, and I have some IAM policies that my function is going to assume. And below that, I'm defining my event source. And the cool thing there is that you'll note I don't have to explicitly define my API here. This implicit definition as an event source is enough for CloudFormation to be able to provision that API in my account. And the line that makes this all possible is the transform line. This is what essentially tells CloudFormation to take this template and transform it into a full-blown CloudFormation template under the covers. And that full-blown CloudFormation template is what CloudFormation is going to use in order to provision resources in my account. And if you're wondering what are actually the resources that will get provisioned here, then those are the resources in this specific case. We have a Lambda function. We have a couple of IAM resources. We have some API resources. And if you're thinking, these are actually a lot of resources to get provisioned from that short template, then you're actually right. And this is how the full-blown CloudFormation template is going to look like. I think there's some more under the screen over here. And so I don't know about you, but I'd definitely rather code in SAM when possible. OK. So we talked about authoring. We talked about authoring our application with SAM, and then authoring our code with any IDE you'd like. But yesterday, we actually announced an IDE that's optimized for serverless development. And that IDE is Cloud9. And Cloud9 is a fully integrated cloud-based environment with dev environment, with an editor, a terminal, and a debugger. It's accessed through your web browser. And it comes prepackaged with all the tools you'd expect to find for your language of choice. And the really cool thing about Cloud9 is that it's optimized for serverless development in a few ways. First, it's fully integrated with the Lambda environment. And so you can do things like import functions from the Lambda environment into Cloud9. You can do things like deploy your function from Cloud9 back into Lambda. It comes with native support for SAM. So it allows you to generate these templates super easily. And it comes with a couple other tools that we'll see in a few minutes. So again, we can author applications with SAM, author code with any IDE, combine those two into Cloud9 for a great experience. But what about the other two nodes here in this diagram? What about testing and debugging our serverless applications? Well, testing and debugging serverless applications presents a unique set of challenges. And that's true because, first and foremost, serverless means that you don't have to manage any servers, right? And so the underlying infrastructure is abstracted away from you and is managed by AWS. And if that's the case, then how do I make sure that the code that's running successfully in my dev environment will actually run successfully in Lambda as well? Well, ideally, I'd like a few things to happen. I'd like my code to run in an environment that essentially has the same, runs on the same OS, has the same libraries, has the same runtime that Lambda has in production. It would also be great if configured limits, such as memory and timeout, could be enforced locally, because if my function takes 30 seconds to run and my configured limit was 3 seconds, then I'd rather find that out as soon as possible and not find that out as I'm deploying to production. For high fidelity, I'd also love it if my response object and logs would be essentially mimicked locally. And lastly, it would be great to be able to generate test events in an easy fashion. And the reason this is less than straightforward is because Lambda has over 15 event sources, and they each emit their own specific event pattern to Lambda. And just to give you one example, this is an S3 event, an event that S3 sent Lambda. And if I wanted to test this function locally, I'd have to retrieve this event, save it, and customize it for my testing needs. Now, this isn't the most complex thing in the world, but nevertheless, it can be time-consuming and a bit annoying if you have to do this over and over again for multiple event sources in your serverless application. And so I'd like to introduce a tool that essentially bridges or helps you overcome all these challenges. And that tool is SAMLocal. And SAMLocal is a CLI tool that helps you locally test your Lambda functions or your serverless applications. It's going to allow you to more quickly iterate on your functions. And it's going to maximize the chances that your code will actually run as expected in production. And that's true for a few reasons. First, SAMLocal runs your code in a Docker container that mimics the Lambda environment. So it runs with the same runtime, the same libraries that exist in Lambda. Secondly, SAMLocal actually enforces configuration limits, things like memory and timeout. If your function is fronted by API gateway, SAMLocal actually lets you ping your API, which is going to execute your function all on your local machine. Alternatively, if your function is triggered by a different event source, then SAMLocal is going to allow you to quickly generate test events for commonly used event sources in Lambda. So one example is this command over here, which helps you generate a test event for an S3 event. All you need to provide it is the bucket and key, and you get your test event. Response objects and logs are also emitted as they would be in the Lambda environment when you run your function in SAMLocal. Your response is essentially piped into stdout. Logs are piped into stdr. And you could actually pipe your logs to any file you'd like, which makes life easier when you're automating testing against SAMLocal and would actually like to persist your logs for further inspection. SAMLocal exposes a debugger port, so you can essentially debug it using any IDE. We'll see a quick example of debugging with SAMLocal later on. It currently supports Java, Node.js, and Python. And the easiest way to install SAMLocal is just to run npm install. And SAMLocal is completely open sourced and written in Go, so you can just go on the GitHub repo and download the binaries. We make those available over there. Or if you really want to, you could always just download the code and compile it. And I won't spend a lot of time here. I just want to quickly go over a couple of important commands. The first one is the local command, which we'll get to in the next slide. But the second command that's interesting here is SAMValidate. And SAMValidate actually validates your SAM template against the actual SAM specification on your local machine. And so again, giving you that quick feedback loop, because if I have a problem with my SAM template, I have some bugs, something is not configured correctly, I'd rather find that out as soon as possible and not find that out as I'm deploying or as my pipeline is in the works. So what command SAMLocal actually provides you? The first command is start API. And start API starts a local Go HTTP server on your local machine. And again, just explaining the power here, if your SAM template defines 20, 30 APIs that are triggered that are set up to trigger different Lambda functions, you run one command, start API, and all these APIs are essentially available to you or for you to ping on your local machine. The second command here is invoke. And that's the command that essentially allows you to locally execute your Lambda function directly. And thirdly, we have the generate event command, which is the command I showed you before and allows you to generate a test event super quickly. Now, the cool thing about all this is that all of this is available to you in Cloud9. And it's not only available in Cloud9, Cloud9 has actually stripped some of the complexity away and provides easy-to-use UI on top of the SAM local commands. So let's take a quick look at how that looks like. OK. So this is the Cloud9 IDE. On the right here, I just expanded this AWS resources panel. And this gives me a couple of options. First, I see my remote functions. So this are all the functions that I have in US East 1. I could click on any of them and do things like import. So essentially, bring that function into my IDE. And once it's in my IDE, I'll see it here under local functions. And then I could do things like deploy it back to Lambda, edit my function, or run it in various different scenarios. And I'll show you that in a second. I can also convert it to SAM to be able to generate that SAM template super quickly. That's already happened, so nothing to show here. OK. So I have one simple function here. Let's just open my index.js file. A super easy, simple function. I'm requiring this GitHub package. All I'm doing is querying repos with this query string, the AWS SAM query string, and sorting that by stars. Now, you'll notice that I'm using the GitHub package, and I don't have any node modules here. But now, because I'm inside an IDE with full IDE capabilities, and I mentioned tools are pre-installed for the language of your choice, so obviously I have npm here. So I can just do npm install GitHub and get my package right here. And so let's try to invoke this function. I can click on run over here. Now, once I click on run, I actually have a couple of options. I can invoke the Lambda function locally. And this is essentially using SAM local under the covers. If this function is fronted by API gateway, I could ping the API gateway local command, which again is using SAM local under the covers. Or I could run these two options remotely. So I could actually run my function in the actual Lambda environment from within Cloud9. Let's stick to Lambda local for now and run this function. OK. So I have an error here. Cannot read property map, and the problem is at line 14. OK. So again, as I mentioned, SAM local exposes a debugger port, allows you to debug using any IDE you'd like. But in this case, again, everything is abstracted away from you and provided in the UI. So I can just set a breakpoint at line 14. And I need to click this cute little debug mode button. And once I do, and I click on run, my function runs, and it stops at the breakpoint that I set. And at that point, I get a debugger, which has everything you would expect from a debugger. So I have watch expressions, I have my call stack, and I also have local variables shown to me here. So let's take a look at the res variable, because that seems to be where the problem lies. So within the res variable, I actually have a data object. And that data object is the one that has the items array. So I'm missing the data object here. OK, let's just continue this invocation. I can add res.data.items here. That should solve the problem. Oh, I need to save my file. OK. So I get a response back. I can see the SAM repo here, 1,500 stars. I can see the SAM local repo, 1,300 stars. OK, so this is running. That's cool. And now, I've tested this locally. I can actually super easily also deploy this back to Lambda. So I just right-click on the function, click on deploy, And this function is now deployed back to Lambda. Now, as I mentioned before, this is a fully customizable IDE, so I could set themes, I could change keyboard shortcuts, I could do anything you'd expect to be able to do in your local dev environment. And my function has now been deployed. And now I can actually get back to my run window, change this to Lambda remote, and invoke my function again. And this time, this function, this response is actually being received from the actual Lambda environment. I'm not running this locally. I actually ran this in Lambda. Remotely? Not yet. Not yet. OK. So that was the Cloud9 experience. And so quick recap. SAM for building applications, any IDE to use your code. Testing and debugging presents multiple challenges that probably don't exist or exist in different forms in other types of applications. But luckily, we now have SAM Local, which helps you bridge those challenges or overcome those challenges, and helps you make sure that you can produce high-fidelity deployment packages. And you can bring all this together in Cloud9 that is optimized for serverless development and provides you with that easy experience with SAM Local and SAM built-in. But the title of this session is Authoring and Deploying Serverless Applications. So let's touch on the deploying part a bit. This is the same diagram I showed you before, the CI/CD diagram, just kind of nicely visualized. If my application is built on top of SAM, then I actually have, and I've had for a while, all the tooling necessary to automate my deployment process. So I can orchestrate all of this with Code Pipeline, which can essentially pull my code from my code repo. Once it does that, it can essentially move my code onto the next stage, which is code build. And code build can pull down any packages, package up my deployment package, and build my application. Once that happens, then I can actually run tests either within code build or by using any of Code Pipeline's third-party tools, which are natively supported. I could do things like use Ghost Inspector for UI testing or use Apica for load testing. And once that happens, I can use CloudFormation combined with the power of SAM to actually deploy my application to multiple environments. But the issue we hear, or we have heard from a lot of customers, is that there's something missing in this chain. And the thing that's missing is that at the end here, we essentially have a binary switch. We have an instantaneous shift of traffic from the old version of code to the new version. And that's not usually how we deploy things. Usually, we incrementally roll out new versions to help reduce deployment risk and minimize blast radius. And so all of you asked us, and we listened. And so today, or this week, we actually introduced safe deployments in Lambda. And there are three pieces to the puzzle here. The first piece is that the Lambda aliases have been enhanced to enable traffic shifting. And that essentially means that they can now point to two different versions and shift traffic between them based on pre-assigned weights. Now, on top of these Lambda primitives, we now have code deploy integration. And with code deploy, you essentially have an automated deployment engine on top of the Lambda primitives to help you automate this whole deployment process. And the third piece of the puzzle here is SAM. And within SAM, this is all natively supported and takes a few lines of code to define. And let's dive deeper a bit into each of these pieces. So first, Lambda versions and aliases. So version is an immutable deployment unit. It's essentially a snapshot of your code and configuration. It's numbered and sequenced. And so version 5 is always going to be newer than version 4. And version 4 is going to be newer than version 3, and you get the point. And an alias is simply a pointer to a version. I think that's best illustrated with an example. So let's say I have a Lambda function foo, and that function has an alias called live. And that alias is serving production traffic. It's currently pointing to version number 5. For me to be able to deploy a new version of my code, what I'd have to do in this scenario is publish version number 6. And once version number 6 is published, I'd have to point the alias to the new version. But again, the issue here is that all traffic is going to be shifted to the new version all at once. So now, with weighted aliases, what you could do is you could actually publish version 7. You could add version 7 to the alias, and just define percentages on each version. And so I could shift 5% of traffic to the new version and keep 95% of traffic pointing to the old version. And so obviously, you have the primitives built into Lambda now. You could either build your own automation system or integrate this into your existing automation system. Or you could simply use co-deploy. And co-deploy is built on top of these primitives and helps you super easily and completely automatically shift traffic incrementally to new versions. And so you can do things. It comes with pre-configured settings. So you could do things like do canary or linear deployments. So for example, I can shift 10% of traffic to my new version and linearly increase traffic to that new version as time progresses. Co-deploy also provides you with the guardrails and validations needed for safe deployments. So for example, you could do things like define alarms within your SAM template. And for each of those alarms, if triggered, they're going to prompt a rollback to the old version. Also, you could define things like pre- and post-traffic test hooks. And those are essentially Lambda functions that run as tests and can be run either before or after traffic is shifted to your new version. And most importantly, all of this is supported in SAM. And just to show you how easy it is to use and do within SAM, I have this simple SAM template here, which essentially just defines a Lambda function. And what I'd have to add here for safe deployments are just these 5 lines of code. This first line is actually a new feature we introduced this week. And what globals allows you to do is to essentially define function configurations for all the functions in your SAM template. So things like nvars, tags, runtime, things that you might have in common for all your functions, you could now define within globals. And for each specific function, if needed, you could also override these globals. So for example, I could define the runtime as Node.js for all the functions, but one function there is Python, so I could just override that within that specific function. And the reason this is powerful for safe deployments is because most often than not, I probably want to define a deployment strategy for all the functions within my application, as opposed to having to define those for each function separately. Next, I have the auto-publish alias line. And what that does is it essentially creates an alias named live, and it auto-publishes a version with each deployment. And those are the kind of underlying constructs that allow co-deploy to act. And lastly, I'm defining my deployment preference. And here, I'm essentially selecting what type of deployment I'd like to happen for my functions here. And so in this specific case, I'm defining canary 10% 10 minutes, which means shift 10% of traffic to the new version. And if everything goes well, after 10 minutes, shift all traffic to this new version. I also mentioned test hooks and alarms. So this is how those would be defined in SAM. You can define pre- and post-traffic hooks. Again, these are just Lambda functions that run as tests. Once they succeed or fail, they need to talk back to co-deploy and let co-deploy know, hey, these tests failed or succeeded, and so co-deploy knows how to act. And alarms, again, could be super easily defined using this alarms construct within SAM. And for each of these alarms, if they're triggered during deployment, then that's going to prompt a rollback to my old version. All of this is super easy to monitor through the code deploy console. So questions such as how much traffic is currently shifted to my new version, have my tests run already, and what was the result. You actually have a log of events, of all the events that happen within your deployment. So any question you'd have about your deployment could be easily answered looking at the code deploy console. So what did we do here today? What would I like you to take out of this? First of all, the Lambda console, well, first of all, different tools fit different use cases. The Lambda console has been overhauled. It's now super easy to use, has an immersive dev environment within it, and should be used for simple applications. If you have a more complex application, define those with SAM. Once you define those with SAM, you can take advantage of tools that are built on top of SAM, such as SAM Local for local testing and debugging. You could use SAM Local with any IDE you'd like. But as of yesterday, we now have one IDE that's optimized for serverless development. Has SAM Local built in, with UI on top of that. So I highly encourage you to check it out for serverless development. And we then touched on deployment. We've had these deployment constructs for a while, but there was one piece missing, one important piece for mission-critical applications, which is how do I incrementally roll out traffic to new versions? That has, again, something that's been released this week. And with code deploy integration built into SAM, it's super easy to now incrementally roll out new versions into production. Lastly, I encourage you to take a look at this page, the Serverless Developer Tools page. It has more information on SAM Local, and also other frameworks and tools that you could use for serverless development. So thank you very much for your time, and don't forget to review this session. Thank you.